Hello everyone, welcome back to another video on Thevenin's theorem. In previous video, I had shown that how to obtain the Thevenin's equivalent of a complicated circuit and then how to calculate the current through the load resistance. In this video, I will be solving a few more problems where we will be calculating the current through the load resistance using Thevenin's theorem. I suggest you to solve the problems by your own, then come to check the solution. The first problem which I am considering is find the current through 10 ohm resistor using Thevenin's theorem for the given circuit in which we have three different sources. So this 10 ohm resistance is actually load resistance. Let's say this is A terminal and this is B. We have to obtain the Thevenin equivalent of this complicated circuit across terminals AB. So first step here is for calculating VTH, we need to redraw the circuit, and when we redraw the circuit we have to remove the load resistance. Rest of the circuit will remain as it is. A and B, we have removed the 10 ohm resistance. Now this is a circuit after removing the load resistance. We need to find out the voltage over here. Let's mark the polarity as this, writing it as VTH. Now we can find out the VTH by applying KVL in this loop. The voltage across the open loop terminals is VTH. Here we have 2 volt source. We can write the voltage drop across 15 ohm resistance and 4 ohm resistance if we know what is the current through these two respective resistances. These currents can be found by assigning the two mesh currents, let's say I1 to first mesh and I2 to second mesh. After this we can apply KVL to find out the value of I1 and I2, and hence we can calculate VTH. This voltage source is of 20 volts. Now when we apply KVL to first mesh, let's mark the polarity of voltage drop as per the direction of I1. So minus 50 plus 6I1 plus 4 into I1, since the current through this mesh is 0 as it's an open loop. So from here we get the value of I1 as 50 by 10, that is 5 amperes. After this we can apply KVL to second mesh. For that, let's mark the polarity of voltage drop as per the direction of I2. So this terminal positive, this one negative. So we have drop across 5 ohm resistance as 5 times I2. Then we have 20 volt source. Then 15 into I2 is the voltage drop across 15 ohm resistance, and this should be equal to 0, which gives us the value of I2 as 1 ampere. Now we have the value of I1 and I2. After this, we can apply KVL to this open loop. So if I start with the 2 volt source, then minus 2, then positive terminal of VTH plus VTH. Then we have the drop across 15 ohm resistance. Since the current through this open loop is 0, so I am writing the voltage drop as per the marked polarity. So this one is going to be minus 15 I2. This is as per the direction of I2, not as per the direction of current of this loop. Similarly, we will write the drop across this 4 ohm resistance as per the assigned polarity due to current I1. So this will be minus 4 into I2 equal to 0. Hence VTH is 2 plus 15 I2, sorry, this should be I1 not I2. Current through 4 ohm resistance is I1. So it's 4 into I1. So 15 I2 plus 4 I1. Now let's use the value of I1 and I2 which we had already calculated. Plus 2, 2 plus 15 into minus 1 plus 4 into 520. So this will give us the value of VTH as 7 volts. So once we have the value of VTH, next step is we need to calculate RTH. Now for calculating RTH, we have to redraw the circuit again by replacing all the voltage sources, all independent voltage sources by short circuit, and if we have any independent current source, that has to be replaced by open circuit. So we have first 6 ohm resistance, then this 50 volt, 2 volt, 20 volt, all these sources they have to be replaced by short circuit. This 10 ohm resistance, it has to be removed from the circuit. Correspondingly, the equivalent circuit now becomes first one replaced by short circuit, then we have 4 ohm resistance, then second source again replaced by short circuit. Here we have A and B terminals where we need to calculate RTH. Then 15 ohm resistance. Here we have 5 ohm resistance, and this voltage source again replaced by short circuit. So now what we have on this side, we have two branches which are connected in parallel. 4 and 6 they are connected in parallel. Here also we have parallel combination of 15 and 5 ohm resistance, and after that they are in series. So RTH is 6 in parallel with 4 in series with parallel combination of 5 and 15. 6 in parallel with 4 is 2.4, 5 in parallel with 15 is 3.75. Hence the RTH is 6.15 ohm. So once we have the value of VTH and RTH, then we can draw the Thevenin equivalent. VTH is 7 volts. Then we have 6.15 ohm RTH, terminal A and B, where we are going to connect the load resistance, that is 10 ohm resistance, and we have to find out the current through this 10 ohm resistance. This I10 ohm is now 7 by 6.15 plus 10, and that is 0.433 ampere. Let's take one more problem. Question is, find the current through 1 ohm resistance using Thevenin's theorem. The circuit here is this resistance is 1 ohm resistance, that is load resistance. Here we have a voltage source 4 volts, 2 ohm, 3 ohm, another current source over here which is supplying 3 ampere current. So these two are load terminals, considering this one is A and this one is V. Again, as we need to apply Thevenin's theorem, so we need to find out VTH and RTH. For finding VTH, we need to redraw the circuit again. So when we redraw the circuit, here we have 1 ampere source, 2 ohm resistance, 3 ohm resistance. This 1 ohm resistance, which is actually load resistance, that has to be removed. Here we have 4 volt source and 3 ampere current source over here. Let's mark the polarity of voltage VTH like this, with terminal A positive, terminal B negative. Now we can find out the voltage VTH by applying KVL to this open loop. So when we apply KVL to this open loop, we need the current through this 2 ohm resistance. To find out the current through this 2 ohm resistance, we actually need two mesh currents. Let's assign the mesh current I1 to first mesh, I2 to second mesh. Now what we see, in first mesh we have a current source in the outer branch, so we will get the answer of I1 directly as 1 ampere. Similarly, in second mesh, again we have a current source of 3 ampere in the outer branch. We will get the value of I2 again directly. So I2 is minus 3 ampere. Since I2 and 3 ampere current source, they are just opposite to each other. Current I2 is flowing in downward direction while current source is supplying the current in upward direction. So once we have the value of I1 and I2, then we can have the current through this 2 ohm resistance, and then we can apply KVL to this open loop. So when we apply KVL to this open loop, starting from 4 volt source minus 4, then drop across this 2 ohm resistance as per I2, since we are applying KVL. in some part of mesh 2 plus 2 into I2 minus I1 plus VTH equal to 0. So this will give us the expression of VTH as 4 minus 2 into I2 minus I1. I2 is minus 3, I1 is 1. So this will give us the value of VTH as 12 volts. So we are done with the first step. Then we have to calculate RTH. For calculating RTH, the voltage source has to be replaced by short circuit. The current sources, are to be replaced by open circuit. 2 ohm resistance, 3 ohm resistance. Here we have the voltage source of 4 volts which will be replaced by short circuit. 3 ampere current source replaced by open circuit. 1 ampere source again replaced by short circuit. We have to calculate RTH. Now what we see that between terminals A and B we have only one resistance. So we don't need to do any calculation. We have the direct answer of RTH as 2 ohm. 3 ohm resistance is not playing any role for calculating RTH. So we have the Thevenin equivalent as 2 ohm in series with 12 volts, and between terminals A and B we have to connect 1 ohm resistance. I1 ohm is 12 on 2 plus 1, which will give answer as 4 ampere. The last problem which I am considering for Thevenin's theorem is of the circuit which looks like a Wheatstone bridge. Here again the problem is that we need to find the current. Question statement is determine the current through 24 ohm resistance using Thevenin's theorem. Now the circuit here is that we have 5 resistances, and here we have a voltage source 220 volt. This resistance is of 30 ohms, 20 ohms, 5 ohm, 50 ohm, 24 ohm. So this 24 ohm resistance is actually load resistance. Now we have to find out VTH and RTH across these two terminals. Now for VTH, what we need to do, we need to remove the load resistance. So I have just removed the load resistance from here. Let's mark the polarity of VTH like this. We can find out the VTH by applying KVL either in this loop or in this loop. Both are open loops. Across the open circuit, we have assigned the voltage as VTH. But for that, we need to find out the currents through the respective resistances. For finding out the currents, what we see that we are having two meshes. This is first mesh consisting of 220 volts in 30 ohm resistance and 50 ohm resistance, and this is our second mesh. Let's say the first current is I1, the current through second mesh is I2. We need the value of I1 and I2 to calculate VTH. Now if I want to apply KVL over here to find out VTH, then the equation will be starting from this 20 ohm resistance. This will be the voltage drop polarity. Then voltage drop polarity across 30 ohm resistance is lower terminal positive and upper one is negative. So it will be 20 into I2 minus VTH plus 30 into I2 minus I1 equal to 0, which will give us the VTH as minus 30 I1 plus 50 I2. Or we can even apply KVL in this path as well. If we apply KVL in this path, positive, negative, starting from 5 ohm resistance, 5 into I2 plus 50 into I2 minus I1 plus VTH equal to 0, which will give us the expression of VTH as 50 I1 minus 55 I2. So you can go with either this expression or this expression. From both the expressions, you will get the same answer of VTH. But for that, we need the value of I1 and I2. Now what to do for that? We need to apply KVL in first mesh. In first mesh, we have to assign the voltage drop polarity according to first mesh current plus minus. Then this terminal will be plus, this will be minus. Now this yellow color is for mesh 1. Let's mark this voltage drop polarity inside mesh 2. Mesh 1 equation will be minus 220 plus 30 into I1 minus I2, then plus 50 into I1 minus I2 equal to 0. Hence the equation is 80 I1 minus 80 I2 equal to 220, or 4 I1 minus 4 I2 equal to 11. This is first equation. Similarly, we need to apply KVL to mesh 2. For mesh 2, I am starting with this 20 ohm resistance. So it's 20 into I2, then drop across 5 ohm resistance plus 5 into I2. Then we have drop across 50 ohm resistance plus 50 into I2 minus I1. Now the resultant current is as per the direction of I2. And then we have the last resistance 30 ohm. Again, we need to calculate the current as per direction of I2. It will be I2 minus I1 equal to 0. So this equation is simplified to minus 80 I1 plus 105 I2 equal to 0. Now solve these two equations simultaneously to find out the value of I1 and I2. I1 is 11.55 amperes. I2 is 8.8 ampere. Now we can use the value of I1 and I2 either in this equation or in this equation. Both the equations will give us same answer. So if I use second equation, then VTH is equal to 50 into I1 minus 55 into I2. So 50 into 11.55 minus 55 into 8.88, and hence this VTH is 93.5 volts. So we are done with one part. Next part is we need to calculate RTH. Now for calculating RTH, we have to replace this 220 volt source by short circuit. So 220 volt source is replaced by short circuit. Here we have 30 ohm resistance, 20 ohm, 5 ohm, 50 ohm, and we need to remove this 24 ohm resistance, that is RL, and calculate RTH between these two terminals. Now it's better to redraw this circuit to understand that how these resistances are connected. For that I am marking the terminals. Let's say this is A, this one is B, C and D. We need to calculate the resistance between terminals B and D. What we see over here, A and C, they are short circuited. So basically these are same. So how to redraw the circuit? Mark point A and C and short circuit them. Here we can have B and here D. Now between A and B we have 30 ohm resistance. Between B and C we have 50 ohm resistance. Between A and D 20 ohm resistance. Between C and D 5 ohm resistance. So after redrawing the circuit, it becomes very easy to understand that 30 and 50 they are connected in parallel, 20 and 5 they are connected in parallel, and their resultants are in series. So RTH is 30 in parallel with 50 plus 20 in parallel with 5. So 20 in parallel with 5 is 4 ohm, 30 in parallel with 50 is 18.75, and hence the RTH is 22.75 ohm. So in this type of problem, if bridge circuit is there, it's always better to redraw the circuit to understand that how the resistances are connected. After this, we have the last step where we need to draw the Thevenin's equivalent with VTH as 93.5 volts, RTH 22.75, and between the load terminals we have to connect the load resistance back, that is 24 ohm resistance. We need to find out the current over here. This I24 ohm is 93.5 divided by 22.75 plus 24, which is equal to 2 ampere. So I hope these problems are helpful for you in understanding Thevenin's theorem. In all these problems we have considered the cases when we have only independent sources are there in the circuit. Bef- Before moving on to the case when we have the dependent source in the circuit, I will introduce another theorem in the next video known as Norton's theorem. Once we understand that what is Norton's theorem, how to obtain Norton's equivalent, after that we will consider the problems where we have the dependent sources present in the circuit and we have to obtain their Thevenin or Norton equivalent. So if you have any doubts, please do let me know that in comment section. Thanks for watching the video.